Hello everyone, this is my presentation on nuclear power generation plant, myself Pragya Pranati. So the contents of this presentation are introduction to nuclear power plants with its basics. Further we'll move on to the components and the schematic diagram of the station and the types of nuclear reactor along with the safety systems, nuclear fuel cycle, environmental impact and waste management. Next comes nuclear power plant rules and regulations, the future of nuclear power and the conclusion related to this presentation. So for the introduction, we have nuclear power plant harnesses the extraordinary power of the atom to generate electricity on a large scale. At their core lies a remarkable process called nuclear fission, where the nucleus of an uranium atom is split, unleashing an immense amount of energy. This energy is converted into heat, which is then used to produce steam. The high pressure steam drives a turbine connected to a generator, creating clean and reliable electricity. Nuclear power plants have a vital role in providing a significant portion of the world's electricity needs while producing minimal greenhouse gas emissions. With rigorous safety measures, advanced technologies, and robust waste management protocols, these plants continue to evolve, ensuring a sustainable and secure future for the generations to come. So, this was about the introduction to nuclear power plant. Next, we have the basics. So, the nuclear power plant consists of a nuclear reactor, the core area where the nuclear reactions occur, producing heat for the electricity generation. Next comes the most important thing, the fuel. Enriched uranium is used as a fuel arranged in rods within the reactor core. So, the uranium basically there are uranium rods arranged inside the nuclear reactor, which is basically the fuel for the reaction. The fission reaction, the exact chemical reaction is behind the scenes. Steam generation. So the heat from the reaction is used to generate heat, and then the turbine and the generator which is driven by the steam. The safety and waste management. This is one of the most important part of the nuclear plant because rigorous safety and systems are important to ensure safe operations and proper handling of radioactive waste. So the components of a nuclear power plant are on an elaborating it, fuel. So the uranium fuel is basically the pellets of uranium dioxide arranged in tubes to form fuel rods. The moderator, material in the core which slows down the neutrons released from fission, so they cause more fission. It is usually water but may be heavy water or graphite. Heavy water is D2O, which is D2O, which is quite a common moderator. Control rod or blades, neutron absorbing materials such as cadmium, hafnium, or boron, which are inserted to control the rate of reactions or to halt it. A coolant, since high energy is produced, so a coolant is necessary, so water acts as the coolant. Primary coolant, the pressure vessel or the pressure tube, usually a robust steel vessel containing the reactor core and moderator and coolant, but it may be a series of tubes holding the fuel and conveying the coolant to the surrounding moderator. Steam generator, part of the cooling system of pressurized water reactors, where the high pressure primary coolant bring heat from the reactor is used to make steam for the turbine in the secondary circuit. Containment, the structure around the reactor associated steam generators which is designed to protect it from outside intrusion and to protect those outside from the effect of radiation in case of any serious malfunction inside. It's typically a meter thick concrete and steel structure. The schematic diagram of a nuclear power plant is as follows. The main structure consists of a generator, a turbine, a condenser and the reactor vessel with steam generator as evident from the above picture. So there are basically four types, major four types of nuclear reactor: pressurized water reactor, which uses the high pressure water, the boiling water reactor, advanced gas cooled reactor, and fast neutron reactor, which uses the energy of fast moving neutrons. The safety instruments. The safety instrument system, independent system that continuously monitor and control key parameters, ensuring safe operation and initiating protective actions when necessary. This is the primary safety instrument and protocol which is followed at every nuclear power system. Reductance and diversity. Safety systems are designed with reductive components and diverse technologies to ensure multiple layers of protection and minimize the risk of single point failures. Seismic and natural disaster resilience. Nuclear power plants are engineered to withstand seismic events and natural disaster with robust design features and reinforcement measures to maintain structural integrity. Operator training and human factors. Comprehensive training program and ergonomic design considerations aim to enhance operator skills, situation awareness, and decision making during normal and emergency operations. Safety culture and regulatory oversight. A strong safety culture fosters a proactive approach to safety, while independent regulatory bodies provide oversight and enforcement of safety regulations. Lessons learned and continuous improvement. So the life cycle of a nuclear fuel. In this diagram, I'll be explaining the life cycle. So first we have the radioactive uranium atom, which is split into cesium-137 and strontium-90, which are the lower, which contains lesser number of protons. Then these constitute the free particles neutron and proton, which break down with release of huge amount of heat. This huge amount of heat is used for power generations in the process, like this heat is used to convert water to steam, which is used to drive turbines, and the spent waste is cooled in a pool, and the waste is sealed in dry cases. Environmental management and impact and waste management. So as we can see the data here, the total amount of waste is 1,188 tons, and the amount of conventional waste is 95%. So as far the data says, 76% waste can be recovered as and 66% as material and 10% as energy. The 10% or another 10% lands in landfills, and the 9% hazardous waste must be moving forward for further processing. So the nuclear waste is basically amounts to 2% of the interim storage at the power plant premises, and final deposit in the final repository. Power plant regulations. So the power plant regulations include license and permitting, obtaining permit and license for construction, operation, and decommissioning of nuclear plants. Safety standards, stringent regulations ensuring safe design, operation, emergency preparedness, and waste management of nuclear plants. Radiation protection, limits on radiation exposure, monitoring and management of radioactive materials from nuclear plants. Security measures, regulations to protect against threats such as sabotage, theft, unauthorized access to nuclear plants. Environmental protection, regulations addressing environmental impacts including water intake, waste management, and radioactive material release. Future of nuclear power. In the roadmap, the amount of energy provided by nuclear nearly doubles between 2020 and 2050. To achieve this, new capacity additions reach 30 gigawatt per year in the early 2030s. Global carbon emissions have been rising sharply since the start of 20th century, and countries have been adopting various policies in recent years to reduce greenhouse gas, which includes switching to nuclear energy. Safety is a paramount concern in the nuclear power industry, and the future will bring further advancements in safety measures for nuclear power plants. These may include enhanced passive safety systems that can automatically shut down reactors and cool them without the need for human intervention. Additionally, new technologies and materials will be developed to withstand extreme events such as earthquakes or severe weather conditions, ensuring the resilience and reliability of the nuclear power plants. Conclusion, I would like to say that the future of the nuclear power plant lies in advanced reactor design such as generation for reactors, which offers improved safety, efficiency, and waste reduction. Nuclear power plant regulations encompass licensing, safety standards, radiation protection, safety measures, and environmental safeguards. These regulations ensure the safe construction, operation, and decommissioning of nuclear plants with a focus on minimizing risk to workers, the public, and the environment. Stringent safety measures, including passive safety systems and resilient materials, enhance the reliability and public confidence in nuclear energy. Adhering to the nuclear power plant regulation enables the industry to mitigate risk, minimize environmental impact, and contribute to a low carbon energy future. For the references, we have the electrical and electronic books by Hughes and some of the mentioned sites. This was all about my presentation. Thank you and have a nice day.